All right, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap. I'm really excited about this one. We have demos and all kinds of good stuff. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the DevOps.com website too, so you can always find it there. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's presentation, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you will be one of our 4 lucky winners. All right, we'll go ahead and kick off today's webinar now, which is Wishes Do Come True, Fast Development, Secure Delivery. Our speakers today are Tomas Gonzalez, who is a partner architect at Snyk, Sam Olukotan, who is a solutions engineer at CircleCI, and Rob Cresswell, who's architect at Snyk. Thank you, gentlemen, for joining me today. Really excited about today's presentation. Appreciate you being here. And Tomas, you're going to get us started, right? So I'm going to go ahead and take myself off camera, put myself on mute, and let you get right to it.
Absolutely. Thank you, Charlene. That was a lovely introduction, very festive, much appreciated. We do have a great lineup for you today with Rob and Sam and myself here to talk to you about the combination of fast and secure delivery. Sam, if you could go to the next slide real quick to go over what we have for you today. So first off, we're going to be talking about, Sam will talk about continuous delivery, how that fits into CircleCI's paradigm. Then after that, we're going to hand it over to Rob. Rob will talk to us about continuous security. So you can see continuous is definitely a trend that we're going to be latching onto as a theme for this presentation. After that, we're going to see all this in action in the form of a demonstration. Then, as Charlene indicated, we'll be opening it up for questions. I also will be moderating questions as they come in on the GoToWebinar chat and questions feature. So if you have any during the presentation, please feel free to ask. Now, without further ado, I think we'll go ahead and kick it off. Sam, I will now pass this over to you.
Thank you, Thomas. As Thomas mentioned, I will be talking about continuous delivery over the next few minutes. And when we talk about continuous delivery, we usually talk about that within the context of CI/CD. CI being continuous integration and the CD half being continuous delivery. So when we talk about continuous integration itself, we're usually talking about the practice of building and testing the changes to your code base and to your user environments using automated tools. The key idea here being that the process is automated. When we talk about continuous delivery, on the other hand, what we're talking about is the practice of automatically deploying those software changes you've made to your target environments. So you can think of the continuous integration piece as the automatically integrating and building all the changes you've made, and the continuous delivery aspect as getting those changes to your consumers who are actually going to use your product. So when we take a step back and we look at CI/CD together, what we're really talking about is CI, which is pulling in your changes to your code base. You can think of this as your feature implementations, your bug fixes. That's coming in from your code base, be it GitHub or Bitbucket. You're pulling that into your CI. The CI platform is also running your unit tests, your end-to-end tests. The CI platform will also be responsible for doing things like running your security test or scanning for vulnerabilities. And the CD aspect is what handles the deployment to your production endpoints. So with that said, why do people invest in continuous integration at all? Some of the benefits of implementing continuous integration for yourself and for your teams is that it increases the amount of communication and the collaboration that you have around your code base. Furthermore, having continuous integration allows you to run your automated tests to validate your builds. This, along with the last point we make of the continuous feedback loops, really helps to guarantee the quality of your code base through all the changes you're making. The fact that once you make a change to your code base, you get instantaneous feedback on whether that is breaking your test or whether that is breaking your builds allows you and your team to maintain the quality of your code over a longer period of time. Some other benefits of continuous integration is that only the code that has been tested is integrated into the code base. This is one of those side effects that actually ends up ensuring that you maintain quality over the course of your project. And also the idea of merging changes frequently into your release branch plays into what I'm going to talk about in terms of the continuous delivery aspect, which is that you tend to have faster release cycles, the fact that you have this automated process. You also have the ability to trigger on-demand releases because you tend to have your branches that are always ready and set for a deployment at any point in time. The quality benefits of the continuous integration part also lead to lower risk releases as well as the higher quality releases, going back to that idea of maintaining the quality of your code base I was talking about earlier, and having higher quality releases, having less bugs to fix in production, then ends up leading to lower costs for your project overall. So that's CI/CD as an intro. So now where does CircleCI fit into this conversation? CircleCI as a CI/CD platform, you can think of us as the orchestration engine that ties in your code and collaboration tools as well as your runtime concerns. So when I say code and collaboration, I'm typically talking about your source control endpoints. I'm talking about the tools you use for code review, for issue tracking, for dependency management. All of that comes into your code collaboration. And when you do things like push commits or trigger pull requests, CircleCI starts to run things like your test automation. We do like integration to container registries. This is where all the automation starts to kick off in between the code that you're pushing in and the runtime where you want those artifacts or those binaries to be deployed to. To take a look at it in a different way, you can think of CircleCI as the orchestration engine that sits between your creation and the logistics for your application. The creation being where you write your code, where you make your changes, and logistics being where you deploy those changes for your customers to actually use them. So with all of that said, at CircleCI, we like to say that our mission is to make it as easy as possible to go from your idea to delivery. And if we take a step back to this image here, the whole idea of being able to go from idea to delivery is that you create your ideas here, you do your bug fixes, you do your feature implementation, and CircleCI makes it easy, seamless, efficient, and automated to get everything you need to do in between getting your products out into the hands of your customers. So CircleCI as a company, we were founded in 2011. We are now sitting at over 300 employees spread across 5 continents. We help teams build better software. We help them do that quicker, and we help them do that more reliably. Furthermore, we're currently the world's largest shared CI/CD platform, and we got there by running over 1 million builds per day on our platform. At the bottom of this slide here, you'll see a few of our customers, for instance, Stitch Fix, Spotify, Coinbase, and this just goes to show you the scale at which CircleCI is currently running. At this point, I'd like to take a step back from the slides and give you a brief introduction to the platform for those who have not seen CircleCI before. So what I am showing here is a workflow on CircleCI that I'm currently building on a sample project. If we take a step back from this, what I'm doing at a high level here is I am running a build and test job. It automatically deploys to staging. When I get to staging, I hold it for a canary deployment. And so what the idea I am implementing here is that we have a team of QA engineers who come in, they do a visual inspection on staging, and if they are happy with that, they can come in here and promote this job to the canary environment. If I do decide to approve this job for the canary deploy, once that approval registered, you will see here that the deploy to canary job will automatically kick off, and there we go. And so on the right, after the deploy canary, I'm repeating the same paradigm here, where I hold the workflow at the deploy canary step. We go in, we evaluate our metrics, we evaluate our targets, and if the canary environment is behaving as expected, then we can promote the build to production. So just to zoom in here a little bit so we can talk about some of the features that I'm taking advantage of here. Oh, sorry, back a little too far. So here, for instance, on the left, I'm running my build and test jobs in parallel. What I'm taking advantage here is the parallelism and concurrency that is built into the CircleCI platform. In this particular example, I am running these 2 jobs together in parallel because they don't have a dependency on each other. Theoretically speaking, I could have a project in which I am running 5 jobs in parallel, perhaps 10 jobs in parallel, or even up to 100 jobs in parallel. On CircleCI, we allow you to do all of that without having to worry about provisioning additional infrastructure to service each of those individual pieces. So essentially, you can think of CircleCI and the back end as dynamically scaling the CI/CD infrastructure for you for whatever amount of resources that your pipeline demand. The deploy staging job here will wait until both the build and test have succeeded before it starts running. And so this is that idea of the approval job that I took advantage of, which is that it halts the entire pipeline and waits for a manual intervention. So again, the rest of this is just basic features here. I'm also taking advantage of the deployment to multiple endpoints, because from this particular workflow, I can deploy to a canary server, I can deploy to a production server, and I'm also deploying to my staging server over here. So how does all of this get set up on CircleCI? If you're coming from a tool like Jenkins, for instance, you're probably used to configuring things in the UI. On CircleCI, we do everything in a config file. So this is a YAML file that you check into the root of your source code. And as you see, as a YAML file, you don't need to learn any additional scripting languages to pick up CircleCI. Two big aspects of the config file I want to point out in doing this demo is the jobs section, which is a collection of all the commands you need to accomplish a specific task. For this particular example, the tasks I care about are the build, the test, and my deploy jobs. For the build job, these are the collection of commands I'm running. And so beginning on line 36 here, you can see what I mean by the idea of this being just a collection of commands. These are all commands that you could theoretically run at your terminal to get the exact same result. The key benefit here is that you can group them within a logical unit and run them at the same time automatically. You see here on line 30, I'm also using the Docker environment to run this particular job. On CircleCI, we support doing things within Docker containers. You could also do this within a Linux VM, a Windows VM, or a macOS VM. On line 35, I take advantage of the resource class, which is a feature that allows you to specify the size of the resource within which you want to run that build job. And I point this all out just to show that between your resource classes, which on CircleCI, we have the options of choosing from small, medium, large, all the way up to 2XL plus. So between all of those options for resource classes and your options for execution environments, you do have a breadth of options for what you can use for your projects. And so regardless of what you're building today or what projects you might need to build in the future, CircleCI has the infrastructure to support you and your teams. Lastly, before I go back to the UI, I want to touch on the idea of the workflows. So this is a section of the file that allows you to orchestrate how all of these jobs run in relation to each other. So when I demonstrated test and build running in parallel, the reason why they do that is because here within this file, I have not set any dependencies on them. On line 9, however, the deploy staging, this is what allows me to cause the deploy staging job to wait for test and build to finish. It's the idea of the requires keyword that we have here. And if we look at the approval job on line 13 here, the keyword that allows me to make this wait or halt the entire pipeline and wait for the approval is what I specify here as the approval type of job on line 14. So at a high level, just wanted to show you how CircleCI, the fact that we implement our configuration as code and we do everything in YAML, we make it very intuitive for users to pick up our documentation, find the features they're trying to use, drop the keywords they need directly into the config file, and be up and running with your CircleCI configurations right away. So that's what it looks like to set up something that's working successfully on CircleCI. I also want to quickly point out the features we have around error recovery. So take this build, for instance, where I have a failure within the pipeline. If you're coming from, again, a platform like Jenkins, you have to be digging through logs in order to find where the errors have occurred. And this, over time, tends of slowing your team down in terms of how quickly you can restore a failing pipeline back to a successful state. On CircleCI, we give you a clear visual indication of what's failing. Furthermore, you can drive directly into this job and get more details about all the different commands that you've run. So remember how I mentioned earlier in the config file how a job is just a collection of commands that you're running? On CircleCI, within the UI, we give you the outputs of each one of those commands directly from the UI here. The benefit of that is that when something does fail, you get a clear indication of which one of all of those commands is failing as well as the clear error message for what is causing that failure. This quickly gets you up and running on the path to debugging your failed builds and restoring your pipeline to a successful state. In this particular instance, I know that this is a failure due to a flaky download that I have in this particular project. So one thing I can do here is I can take advantage of the rerun option that CircleCI provides, and I can use this feature that allows me to rerun this workflow only from the jobs that have failed. This would allow me to trigger this particular job without starting the entire workflow from scratch. Another one of the features that I really enjoy on CircleCI is this ability to rerun the job with SSH enabled. If I click this, for instance, you will see this job kick off again with the exact same parameters and the exact same build, except in this particular case, we will open an SSH connection on the container that is running this job so that you will have the opportunity to actually debug the job in real time as the build is running. This feature is handy for debugging things like if you misspell an environment variable, for instance, or if you're trying to access commands and you're nested one folder too deep within the directory structure. This allows you to quickly come in here. You can copy this command, drop it within your terminal, and right away, you're going to be debugging live within the container that's building this project. A really exciting feature that I like to point out because it really speeds up the debugging time for engineers on CircleCI. And before I go back to the slides and talk about one more feature, I wanted to show you the Insights dashboard, which is something that we recently built into the UI now. This is a platform, this is a dashboard that lets you track the credit consumption of all your projects at the project level and the workflow level. You can track things like how much credit the projects are burning, how long they're taking to run, the total number of runs you've had, as well as things like the success rate. You can furthermore dive a little bit deeper into this particular project and get a view at a project and branch level that gives you more information or that gives you more graphs that showing you workflows run and success rate, as well as other metrics in terms of workflow duration and credit consumption. A quick note on the workflow success rate, for instance, when we pass it over to Snyk and we start talking about security scan and vulnerability checking, one of the things that allows you to do here is that when your jobs fail, you get a clear indication here, and you can actually come in here and see over time how frequently your jobs are failing, either as a result of failing tests or failing your security baselines. And so now going back, before we go back to the slides, I want to show you real quickly in the config file. I talked about all of these commands being things that you can just normally run at your terminal. Furthermore, you can imagine as these jobs that I have down here, the deploy staging, deploy canary, deploy production, you can imagine that these jobs are not going to be too different from each other. The deployment steps tend to follow the same logic. I'm logging into Docker Hub, I'm pulling in the image that I have built, I install my Heroku CLI, and then I push the image up to Heroku. When you have these repeated patterns like this, instead of copy and pasting these chunks of config from one file to another file or across projects, what you can do on CircleCI is use this idea of Orbs. So Orbs on CircleCI is a feature that allows you to share chunks of your config and share it across multiple projects or multiple configuration files. So you can think of the Orb, in other words, as just a package of CircleCI YAML configuration that contains any commands, executors, or jobs with parameters in them. As an example, here's just a template for a particular configuration file, and I have a command here that just says, say hello. But instead of specifying instead of specifying all of those parameters within one file or hard coding them in, what I can do is take advantage of the parameterization on CircleCI and then check in this chunk of config into CircleCI's Orb registry. For those who are familiar with JavaScript development, you can think of this as an NPM module. So what this allows you to do is define all the logic, all the commands, and all the chunks of configuration you want within this one particular file, check it in as an orb into CircleCI's orb registry, and then import it into any other configuration or any other projects that you might need later on down the line. At CircleCI, we've worked with a lot of our technology partners to write and pre-build a lot of these orbs for you. And some of them we've written ourselves. And even with this presentation we're doing today with a partner like Snyk, for instance, we've collaborated with them to also implement a Snyk orb. So typically I recommend to all customers, once you pick up CircleCI, If there's any third-party tool you're trying to integrate into your workflows or into your pipeline, go into the Orb registry and search for that Orb first, because odds are, given all the integrations we've already worked with our technology partners to create, we might have an Orb already implemented for you. So with that, I'll be passing it back over to you, Thomas, for the Snyk portion.
Awesome. Thank you, Sam. Lots of really good content there. And a lot of truth to what you're saying in terms of, how configuration can be reused, how you can implement approvals into the pipeline, how you can just parameterize and automate and turn all this as code. So that very, very cool to see that. Thank you for that demonstration. And to go along with that, from one of the concepts that we hear about is that security tools traditionally have not been able to keep up with these rapid release cycles that CircleCI is enabling. So now, without further ado, I'm going to pass this over to Rob. Rob is going to talk to us about this paradigm of continuous security, right? How can a modern approach to security really play nicely in parallel with the rapid release cycles and parameterization that you're describing? So we now have this in video form. We learned yesterday that GoToWebinar doesn't like Linux boxes, unfortunately, and Rob, as a developer, is a very heavy Linux user, so he's pre-recorded his section for us. Without further ado, I'm about to hit play on this, and after that, we'll see more in the demo. So, Rob, virtually over to you.
Hiya, I'm Rob. I'm an architect at Snyk, and I'll be talking a little bit about Snyk, what we do, and how we integrate with Circle. So a little bit of background about the company. We've been around for about 5 years now. We're a security company, and we started off kind of focusing on open source libraries and securing those. And nowadays we do a lot of cloud security as well. So focusing on things like containers and infrastructure as code, which I'll dig into in my slides. So yeah, just moving on a little bit into why Snyk does what it does. Over the past, say, 5-10 years, you've kind of seen the developers' responsibility, the developers' scope increase. So in kind of traditional application development, you have to be responsible for your app code. You've got to be responsible for your third-party libraries and dependencies. But a lot of the deployment of infrastructure was handled by different teams, different domains. This has changed pretty rapidly over the past few years, and nowadays devs are often responsible for not just the code, not just the code dependencies, but also the operating system that you're running on, the networking interactions between your different services, maybe even kind of digging into some of the cloud platforms underpinning all of this. And whilst this has meant that we can do things a lot faster, we can get things to production faster. We have all this kind of continuous deployment stuff that is really, really enabled by increasing cloud adoption. This has also dramatically increased scope, and thus has also really increased the risk that the devs are responsible for. And this is a problem, and this is why why kind of Snyk is around to help provide tooling to mitigate these risks. So one of the things, I really like this analogy, one of the things we like to talk about quite a lot is how devs kind of focus a lot on their business logic and the security of that, where that really is probably like the second priority. It's still important from a security point of view, but there's actually a much bigger chunk of your application that you don't sort of immediately engage with if you're just writing code day to day. The first level of this is open source code. So this can, again, on this slide we've put this is kind of 80 to 90%. It can typically be even higher than that. You can see in some ecosystems your dependencies can end up being, sort of 98-99% of whatever you're building and deploying. And a thing that Snyk does quite a good job of highlighting is that vulnerabilities often come from indirect or transitive dependencies. So this is when you depend on something, but that open source library depends on something else. Because then even if you are starting to try and engage with the security side and audit your code, you're rarely going to go 2 or 3 levels deep. At least that's what we've kind of seen from experience. The next level down that I'm going to talk about is container security. So even if you're very, very diligent, you all of your custom code has been well audited, you've checked out all of your open source libraries, made sure they are secure, and then you pull down whatever language specific container from Docker Hub that you want. So maybe like a standard Node or Java container, you deploy your application, you don't think twice about it. And then a week later you get hit by some kind of denial of service attack because of a container vulnerability. I'll show some numbers later on, but a lot of the most popular container images have known vulnerabilities. And these are things that we need to be able to surface to developers so that they know how to either mitigate them or whether they should be paying attention to them or not. And finally, even more recent, I would say, is the increasing amount of infrastructure as code. So this is referring to things like Kubernetes and tools like Terraform and Helm, for example. It's increasingly common to see those files live within the developer's domain, and that means that you've now got to be responsible for not just understanding Linux containers, not just understanding your programming language and its dependencies, but also understanding how to correctly configure container networking or resource access within a Kubernetes cluster. So digging into the open source side of things, this is a nice little example. It's a little bit contrived, but it's a nice little example of this kind of transitive dependency code explosion. So here we've got 80 lines of code and across 3 files or something, and that results in 7, and that is depending on 7 direct dependencies, and that on its own is very unremarkable. But then you see this sort of explosion into the transitives where we have nearly 60 transitive dependencies, and that totals 700,000 lines of code, which is pretty significant at that point. Going back to the container layer, these are the sort of numbers I mentioned earlier. We continue to see container usage grow, globally across all organizations, and these statistics are a really nice sort of summary of the prevalence of security issues within popular container images, which again, just on Docker Hub. These are not people going out of their way to try and maliciously include vulnerabilities. These are just known issues that haven't been fixed. And finally, infrastructure as code. So IAC usage is growing really, really rapidly, and it's just another source of basically misconfiguration issues. It's a really common problem, not just in IAC, but that's somewhere it's being surfaced a lot, is the ability to keep things up to date with known vulnerabilities, like security issues and hacks and all these kind of things. They're not these Hollywood-esque people doing crazy things on laptops. They tend to be people basically just probing the internet for known vulnerabilities. So reaching out to web servers to see if you can determine what web server and version is running, or maybe trying to determine whether there is a known privilege escalation issue if you're able to get into some like a company's Kubernetes cluster or something like that. A really good example of this is that Helm, I think is v3 now, but Helm at v2 was sort of known to be insecure by default. because of the way it used Tiller, which is its sort of sidecar kind of mechanism, and that's like a really significant issue that people need to be able to engage with, and Snyk, it can be used to surface those kind of problems. So a bit more about Snyk itself, what we focus on and why I think it's a pretty good company. We've always been really developer first, really developer focused. We try and make sure that we are integrated at every level that a developer would want to use us. So this is going to be every Git provider, every IDE you could want to have us integrated in. We have a CLI tool, we have a web platform and a web UI. The idea here is really to just reduce the friction. We want devs to be able to use the tool as easily as possible, without having to give up existing tooling, or without having to learn something new. And we find that's been really, really positive. The next thing that I want to talk about is how our tooling kind of works across the whole software development lifecycle. And I'll kind of dig into this a little bit when I talk about our Circle integrations and how you can use this with CircleCI. But we, again, sort of using that tooling I mentioned earlier, we're able to kind of monitor and scan and monitor applications at every level of building and deployment. So you can test something on your laptop, you can test it in your CI/CD pipeline, you can monitor it in production so that any new issues that are found you'll instantly be alerted to. You can monitor your container images, you can monitor your application dependencies, you can monitor your configuration files. So you've got the idea here being that we've got every step of the software development is covered. And then the last 2 points here are security expertise. We have a dedicated security engineering team and a dedicated security research team that work together, and we've always been basically very proud of our vulnerability database, and consider it to be like a very successful part of our organization. And finally, enterprise governance extensibility. This is referring to like reporting, APIs, and all these kind of things that let you engage with the product in a way that you would want to. So, keeping track of how your groups or teams are improving their security posture, using the API to bring Snyk data into your internal tooling. In the case of larger organizations, that's a very common use case. So let's talk a little bit about how we work with Circle. So a very, very common kind of workflow for us would be we want to get Snyk involved at every level of the SDLC. So this is going to start with, over on the left, a developer writing code on their laptop. Maybe they want to write a new feature, and they decide before writing this feature that they're going to just scan this application and check for any existing vulnerabilities. Do like a bit of a cleanup before they start writing new code. They find some issues, and the Snyk CLI tells them how to fix it, or maybe they import it into the Snyk web UI, and that also highlights how to fix it. And once they've fixed it, they'll open a pull request. And this is where the CircleCI kind of integrations start to tie in with Snyk. So there are a few things you could do here. You could use the Snyk CLI to run all kinds of tests as part of your CI. If you want a really, really nice, quick integration point, there's the Snyk Orb for CircleCI, which is like a really low configuration, sort of quick to start with way of integrating Snyk and Circle. And I'll be demoing that a little bit later on. But I think that's a really, really interesting thing. So here in this workflow, you'd have something, you push your fix, it gets tested just to double check that the fix that you've provided is correct. We then trigger a build where we're going to say, build a container image and build our application. And then we want to monitor that container image, we want to monitor the application. So at that point, the idea there being that there is a difference between what's in source control and what's deployed, in the sense that we always want to guarantee that, you know, at the end of the day, that what's deployed is what's secure. It's not enough to just monitor what's in source control, because we need to guarantee that that's making its way to production, and that's what monitor tooling is for. So when we build and deploy these applications and containers, we want to monitor those so that any new vulnerabilities that come in, we can alert you to via Slack or email. But also, you know, we want to use that mechanism to be able to check that fixes that were committed to source were then deployed, because that's obviously, you know, that's the position we want to get to. Yeah, so finally, I just want to kind of summarize Snyk's main points. So again, this developer focus, we want everything to, you know, we're losing my words there. We really focus on making sure that our tooling is easy to use, that the friction is really low, and that we're not just, you know, delivering a list of vulnerabilities to fix. We want to make sure that we have allowed developers to engage with this stuff. So we want to make it easy, but we also want to make it understandable. So, you know, we do things like expose transitive dependency issues so that you can understand how these issues are getting into your code base. We will try and expose, you know, fix information at every level. So again, in the CLI, in your IDE, in the web UI, so that you can always kind of engage with it in whatever platform you want to. Automation, I've actually kind of glanced over this a little bit, I guess, but we really focus on trying to make sure, again, that things are actionable. So it's quite an easy thing to do, relatively speaking, to give devs a big list of things and say, hey, go fix these. It doesn't work. All it does is annoy the security folks, it annoys the developers, and it wastes time for everyone. A really big thing that we try and focus on at Snyk is not just being able to find vulnerabilities, but also demonstrate how to fix them, and in a lot of cases do that for you. So you know, it's a pretty common workflow that you'll have some code being monitored by Snyk, and there'll be a vulnerability discovered overnight, and you get to your laptop at work in the morning, and there's a pull request already sat there saying, hey, there's this vulnerability, press the big green button and we will fix it for you. You know, here's the change log and some other information to help you address this issue. And finally, security depth and coverage. It's a really big focus for us, is our proprietary vulnerability database. We put a lot of effort into finding new vulnerabilities and curating this data, and we have a big focus on broad language coverage as well, and broad ecosystem coverage. So when we talk about that, the reason we sort of distinguishing languages and ecosystems is because, you know, we have maybe multiple package managers for single languages. But yeah, this is again like a really big focus for us. Anyway, that's everything from me for now. So yeah, thank you very much for listening. Bye.
All right, Sam, I want to thank you for recording that elaborate and educational video. And so first off, thanks. Are you there? Can you hear us? Or Rob,
Yeah,
sorry.
yeah.
My bad. Rob, thank you for that. I think it really, for it had been recorded, there was a lot of parallels to Sam's life bits in the form of automating frequent tasks. Really cool shout out to the CircleCI orb that we have, which does help automate testing as part of the pipeline. Also, the point about familiar tools. Yes, Snyk integrates into the tools developers are familiar with. CircleCI integrates into the tools developers are familiar with, using a common language such as YAML to identify how the workloads are configured. these are two very low friction tools for those that are entering this continuous delivery game, but also want to implement continuous security into the pipeline. So, wow. I've been filling in a little bit of time here while I get a second video queued up. Rob, thank you for recording your demo as well, for the same reason that you had to record your slides. So we're hoping to get through the demonstration so you can see Snyk and CircleCI in action together and get an idea of what your delivery pipelines can look like when both your deployments and your security are automated. And then after that, we'll take some questions from the audience. So without further ado, I'm going to kick off the demo and we'll see you on the other side.
All right, demo time. So I'm going to use this time to walk through a demo application and show how we can use Snyk and Circle to fix some vulnerabilities, and then also gate on new vulnerabilities being added. So making sure our security is both improving and then not having new issues brought in over time. So just to kick us off, I've got a very small kind of demo application here. Fairly unremarkable. It's a Node web server with some front-end JavaScript, and it's deployed in a container, which is specified by the Docker file there. And then we're running our testing in CircleCI, deployment stuff as well. The app itself is fairly straightforward. Again, Node web server and a bit of like front-end JavaScript, so we can write things out and it renders it into some HTML on the right hand side. Fairly straightforward. So the first thing we want to do is import this project to Snyk. So we've got this project in GitHub, and we're going to go and import it. It's just called webinar. So at this point, Snyk is going to go out to GitHub and start looking for known manifest files and other files of interest. In this case, we're expecting it to find the Docker file, which specifies the container that we're running on, and also the package.json, which specifies the Node web server, amongst other things, and the front-end JavaScript. So the project's finished imported, and here we go. So we've got our Docker file here, and then we've got our Node stuff underneath. So let's take a look at the Node stuff for now. So straight away we can see that we've found a vulnerability. So let's look at what Snyk offers here. It's showing a bit of information, an overview, and some paths about how which explain how this vulnerability was brought in. So here we can just see that it's a top-level dependency. Our webinar project has brought in Lodash, and we've got this fix vulnerability button. So let's give that a go. So we just hit fix this vulnerability. And we give Snyk a few seconds. And what it will do now is generate a pull request with a bunch of other information in it that we can merge and move forward with. And this is kind of one of the key bits of Snyk, right? Like really getting to automate a lot of this fix stuff. So here we go. We've got our pull request that Snyk has opened. Got it's told us that it's Lodash as expected. We've got some release notes underneath if we want to take a look at those. But let's just go ahead and merge this for now. Yeah, well, there we go. We can see that Circle has said our app scan has passed, so we know that we're secure. So that's good. We'll just merge that for now. We're going to dig a bit more into the Circle stuff later on. Cool. So now that we've merged that, let's take a look at what was going on the Circle side of things. So at the moment, just for the sake of this demo, I haven't set these up as required checks. In production, you would have all of these as required checks so that you weren't just merging code without it passing CI. So let's take a look at the app scan. It's just running a simple test, and you can see that there are no known issues found. If we go back to look at the workflow, we'll see that we also have a container scan, which at the moment is failing. Okay, that seems to have actually found a different issue. Let's dig into that in a bit. for now, what I want to take a look at, I think that's actually just because of my demo setup, unfortunately. So we've confused the workflow a little bit. So let's go back and take a look at our dev workflow. So now that we've merged this code, oh, I know why. It's because we merged it and we've deleted the branch. So then I guess Circle's maybe trying to pull something down that no longer exists. So what we've got here is we've got a difference between a feature branch and a main branch. And on our main branch, we're running a slightly different thing. We can see here we've got app scan and container scan. And on our main branch, we're running app monitor and container monitor. And this is the difference between scanning something that's going into source code and then monitoring something that's being built for production. So we go and look at this app monitor. And just as a frame of reference, that is all happening. If I just refresh GitHub, this is the job that's currently happening because we merged into our main branch. So let's go and look at our app monitor. It's just finished, and we can see the monitor finished, and we've got this this snapshot referenced here. So let's copy that and go and take a look. So this is a snapshot of our deployed code, or soon to be deployed code. And we can see there's no known vulnerabilities found because we've merged that fix. Great news, we're in a good position here. Let's go and take a look then at the container monitor, see if that's still going on. Just refresh to let things catch up. That's still ongoing. So what we'll do at the meantime is go back to the CircleCI, take a look at what was going on with that container. So we glossed over this a little bit earlier, and this is at a much worse vulnerability state right now. So let's take a look. Here we can see our current base image that we're using is this node 14 one. An alternative that Snyk is suggesting, and this is like a really big part of the sort of educational part I mentioned earlier on, is really highlighting to devs that there are alternatives that are trivial to use here. So we've got this is telling us to use this slim image instead of this stock image. And that'll immediately drop 240-ish known vulnerabilities, which is a pretty amazing thing for a low friction, low input effort from a developer. So let's give that a go. And copy that. And let's just open a terminal quickly. We'll check out a new branch. We'll just put fix Docker file. Open our Docker file. We will paste in that new image. We'll add a commit message, just something simple. If I could type properly. Ooh. And then we'll open a pull request. Cool. Right. And then let's go and take a look at our pull requests. And again, just for the sake of the demo, we don't want to wait for all this to pass. We're just going to merge this straight away. And now let's go back to our, I've lost it, there we go. Let's go back to our project and see where we are with some of the earlier work we kicked off. So this was our last monitor that happened. Again, this was telling us that we'd shipped something into production, but this is what we currently have in production, which we believe we've now fixed. So let's go and check in on our pipelines, see where we are at. Great, so we've merged everything and our pipeline's going through. So while that's happening, I want to take a quick look over our CircleCI configuration. So what's really interesting here is the use of the Snyk orb, which is a really minimal, low friction way of getting started with Snyk. If we scroll down to its usage, we can see we've defined two jobs in Circle. We've got this app scan and then this container scan. And they're behaving in slightly different ways. So both of them take in also, you'll notice this monitor on build, which is parameterized, which lets us choose whether to monitor or not. So the trick here is that we only want to monitor our main branch that's being pushed to production, not all of our feature branches. And you can see here that for the app scan, we've got fail on issues true, because we know at the moment that we have no vulnerabilities. We just fixed that application vulnerability. But for our container scan, we've got fail on issues false. And part of this is because we want to be able to surface our vulnerabilities and start to fix them, but we don't want our developers to be completely blocked behind a mountain of security issues. Obviously, in an ideal situation, we would stop and fix all of these maybe straight away. But the reality of this is you can't just down tools most of the time whilst you sit there and read up about Docker container vulnerabilities all day. And then when we look at the actual workflow, we can see here that we have the different definitions which calls these app and these scan and monitor differences. So we've got app scan, which runs on every branch except for dev, which is our main branch. Same for container scan. And then we have the respective monitor parts, which do run on dev. Let's go back and see if how our pipeline is going for our merge. So this is our merge here, and everything is now passed. So let's go see what that container monitor looks like. So we had our container monitor, and this is the thing that we should expect now to be in a better state. So let's again have a look. Let's copy that link, take a look. Great. There we go. Straight away we can see we have no base image advice, so Snyk has no further recommendations that we believe would be a low friction change. And we can see that our issues have dropped to 57, down from 295, was it? I've forgotten the number already. So I think that for me is a pretty nice demonstration of how Snyk works. We've now got, if I just refresh, you can see in the meantime that Snyk has also reacted to the push event and updated the source code monitor. So there you see we've got this which represents our code. Ooh, highlighted the wrong thing. We've got this webinar bit with the GitHub icon, which represents our code in source control, and then the other two entries there represent the application being monitored and the Docker image being monitored. So there you can see we've now got a vulnerability-free application and a greatly improved Docker container, while still surfacing those vulnerabilities and leaving them for devs to address properly in the future. Anyway, that's everything from me. So thanks very much for listening. Bye.
Awesome. So I'll make sure to get the names right this time. Rob, thanks for the demo.
No worries.
Really cool to see those capabilities together with Circle, and just overall some of the things that Sam showed just get me thinking about some of the things that you showed and how they could work together. For example, that the approval workflows that Sam had set up in the pipeline to choose whether a pipeline can be decided to run. You can use that together with a security check in case there is a fail on the Snyk step in the pipeline, to still have a way for a user to manually approve that and let the pipeline continue, is something that does not totally inhibit developers from releasing in their applications. So that's one thing that immediately comes to mind, is like, oh, for a future demonstration, this would be really cool to put together. But overall, thanks for that. So now, Sam, Rob, any other thoughts before we recap what we just saw in the demonstration and go from there? What do you guys think?
Well, if Rob has nothing else to add, I would just like to just quickly summarize and do a recap of what he covered and what I spoke of as well. And so from Rob's presentation, I think we got a good idea of how to configure CircleCI and how to verify your security and infrastructure as part of your deployment. Rob also showed us how to use Snyk to fix security and configuration issues. And as part of my demos, I did show how with the CircleCI Insights dashboard, you can track how things are passing or failing within your pipelines. And so that's a high level of the things we covered between CircleCI and Snyk, both tools in partnership. There was a lot more you can accomplish, but as a result of the time constraints, those are the things we were able to touch on today. However, if there are any questions, any features, any things that we kind of breezed by and you wanted to revisit, now we make some time for some questions and answers.
Yeah, well, while we give time for the questions to come in, definitely am curious about what organizations can learn about the security in their software development lifecycle through the Insights capabilities. Like how much pipeline runtime is spent doing security tasks. Why do security tasks commonly fail? You know, or why do they commonly succeed? You know, these are all things that, you know, Insights might be able to surface. So, Charlene, do we have any questions that have come in from the audience?
We do have questions. Just a time check though, we only have 5 minutes until the end of the webinar. So I think we only have time for maybe 1 or 2 questions. So just kind of setting the parameters there. So sorry about that. First one is, how does your solution work with AWS, Azure, Google Cloud, IBM, VMware Cloud?
Cool. So I can take this from the Snyk side. I do believe I responded on the chat, but for the benefit of the audience, we from Snyk operates on the applications. Where those applications are going to be running at the end of the day, whether it's an Azure environment, an AWS environment, we're agnostic to that. You have the ability to deploy wherever you wish. Code is code is code. A container is a container. That's one of the benefits of containers, actually, is abstracting away the infrastructure, whether it's a Kubernetes cluster on cloud provider X, Y, or Z. You still have to worry about the same risks. And then the other side, we do have integrations with a lot of the runtimes. So AWS Lambda, Azure Functions, IBM Cloud Foundry, VMware's PKS. You can monitor applications with Snyk that have been deployed into those environments. Sam, is there something you wanted to add from the Circle side?
Well, thanks, Thomas. And at CircleCI, our approach is very similar to the one you described at Snyk, which is that CircleCI is unopinionated about the deployment endpoints that you choose to push your applications to. So as Thomas pointed out, as Snyk supports Azure, AWS, GCP, same thing at CircleCI, we actually have Orbs that allow you to integrate with all of these vendors independently of where you want to finally deploy your final applications.
All right, great. Well, unfortunately, we're 3 minutes to the top of the hour. So unfortunately, that's all the time we have for questions. If we didn't get your question answered, please know that the folks at Snyk and CircleCI will be getting a copy of all of the questions that came in. And I am sure that they will be more than happy to follow up with you offline to get your question answered. Also, a quick reminder that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following the webinar, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Guys, I did mention at the top of the hour we'd be doing a drawing for 4 $25 Amazon gift cards. So let's go ahead and get that done before we close things out. Today's winners are Ann C. Congratulations, Ann. Devin A. Congratulations, Devin. Kyle K. Congratulations, Kyle. And finally, Ethan B. Congratulations, Ethan. We'll be following up with all 4 of you offline to get your Amazon gift card over to you. So please check your inbox. If you don't see it in your inbox, please check your spam folder. Okay, Tomas, Sam on screen, Rob off screen. Thank you, all 3 of you, so much for such great information, great presentation, lots of good stuff, lots of really good stuff. So thank you, I appreciate it.
It's been a pleasure to be here.
All right.
Thank you for having me.
All right. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.